Hi everyone, my name is Lopez Barron, currently a Lead Assets Technical Director at Animal Logic, and I'm excited to welcome you to this presentation where we're using the freely available project ALab to share a glimpse of some of our USD workflows. Joining me on this presentation, we'll also have Ankit Sinha, Balaji Kutti Premkumar, and Mohamed Kamal. ALab is an example of how Animal Logic's USD production assets are created and provides an excellent showcase of the capabilities of Solaris and Karma, as you can currently see on this Houdini 19 scene. If you downloaded ALab on its first release, just make sure to use the Upgrade All Like Primitives HTA that comes with Houdini. Then it should start rendering properly. We need this since like definitions had some changes on recent USD versions. We found Houdini Solaris to be very extendable, letting us build assets pipelines in USD while still being in control. In this video, we'll have a look at how this flexibility looks at Animal Logic, starting with how the asset I/O works from an artist's point of view. Then, we'll deep dive into USDShade Basics in Solaris and how we've extended it to fit the requirements of our proprietary renderer Glimpse and its material layering and override system. Finally, we'll explore our tree building system Spruce, which has been recently migrated from our proprietary toolset to Houdini, which enables use of powerful USD features like point instancers and value clips in Solaris. We're in the process of adopting Houdini 19 internally. These demos will be using 18.5. So let's get started. Right now we have Houdini 18.5 open, and everything starts with Production Explorer. This is the view that people use to select the context that they are going to work on. In this case, I am loading the lab. Once it loads, we can cook just to see on our viewports what are the contents. Okay, so this is the lab. Let's find something that we want to modify. So in this case, we want to go to a shelf from these books. And imagine that I just want to make a change, but I want to know how this will look in the context of the lab. So first of all, because we're in the context of an environment, we don't have lights. So I will just drop an asset scene render, which brings some of our built-in light rigs for look development. And let me just create a camera from our current view. So since the default light rig that I have just brought is a default neutral exterior one, I will go ahead and hide the shade group for demonstration purposes. And now I can start rendering in Glimpse. So once the rendering starts, let's just update the camera to be the one that we just created. Okay, so let's say that I just want to make a light tweak. In this case, I want to go from this red color to a little bit of a green. So what I can do is in the viewport, I can select the prim that I want to modify. And we have extended the context menu from Solaris to include the ability for an artist to modify assets based on the selection that they are making. So in this case, I can go to the surfacing assets affecting my selection, and I can find the look fragment. Once I locate that fragment, I can just build from the selected version. This will load what we call a fragment container into my scene. A fragment container is the HTA that keeps the Solaris work area nodes that were used to create the USD opinions that we see on our current stage. It is essentially the authoring state as how this was last published by the artist. So if I preview this build HTA, I should see the exact same contents. Okay, this matches exactly to what we had before. But if we dive inside the Solaris work area, we will see all of the lob nodes that are currently describing these USD opinions. And I can dive into the material library assignment where we have. And in this case, I will just locate the material override that I am interested in, and I can start changing the hue until I find a little bit of a green. We will go into a deep dive of these surfacing workflows in a little bit. So let's just say that I am happy with my changes. I can just update the check-in comment with something meaningful for other artists seeing my update, and I can check in my container. This will export the USD contents from Solaris, as well as keeping a network of my work area contents ready for my next checkout. Upon every check-in request, there is an additional validation step that is executed and appears as a validation pop-up dialog for the artist to see. This gives the artist a chance of seeing everything that they are doing that might be either a user error or a failure in some other place, but this helps keep the pipeline clean with as few errors as possible. In case of emergency, the users are able to check in regardless of validation error, but we try to discourage that. So while I come and fix my errors here, let's go with Ankit and Balaji so that they can give us a walkthrough of the details of these USD Shade workflows. Over to you, Ankit.
Thanks, Chris. At Animal Logic, we used to have our own proprietary shading workflow called Ash, but now we are shifting towards a USD Shade workflow, and following presentation will give a basic insight of our USD Shade workflow. But first, let's start with some USD Shade basic with simple Houdini file setup, where I have this sphere node that creates a sphere prim under root geo. I have this material node which has a prefix of root material and a render mask of glimpse, and then I have a camera. Let's jump inside a material library. I'll drop a subnet. I'll change the name to sphere_matte, and I'll switch on the material flag on it. Let's jump inside. I'll create an incandescent shader, and I'll connect the surface to the output. And then I'll promote the input color so that we have an interface of color. Now I'll assign the geometry, sphere 1, and I'll hit a render. This is a glimpse renderer. This is our proprietary renderer, and it renders white. Now I'll go back and change color from white to maybe red. And yeah, this is red. Let's check the USD data that got generated from our shading network. If I go into Lop Action Active Layer, I should be able to see the data. If I scroll down, there's a prim called Sphere Matte, which is a material prim. It has a color interface, which is red, and it's connected to Glim incandescent input. On to some cool stuff. What I've done is the USD shade data that got generated from our shading network, I've exported that to a file on disk. So you can see the file name is called sphere_matte. There's a material prim called sphere_matte. There's a color interface, which is red, as it was in our previous example. And let's jump into Houdini file. And you can see it doesn't have any material right now, it's just a sphere 1. And there is our glimpse render view, which is gonna render live interactively. Now I'm going to drop a subnet, rename this subnet to sphere_matte, and switch on the material flag on it. Now, instead of creating network, I'm going to modify the interface to reference our file on disk. I'm going to add the same color interface so as to match our original material. I'll call it, I think it was called call, and the name was color. Our label was color. Then I'll add from node property. So these are the parameters that are required to reference a file from disk. The first one is reference type, and then there is something called base asset path and base primitive path. And I'll hit accept. Now I'll change reference type. I'll change color to red to match our previous interface. And I'll change reference type to reference. I'll add the file from disk as a reference file. And the prim sphere_matte as our reference prim. And if I've done everything correctly, now our sphere should render with incandescent shader and red. So let's hit render, it's red. Now I'll go back and change the color. Yeah, and it's rendering green. So you can see how you can compose a material that has been exported as USD Shade on disk. This Houdini native feature actually enables our artists to use material that has already been exported just by changing the parameter for their local asset without actually having to change the network. We saw that USD Shade worked well as is, out of the box from Houdini. But at Animal Logic, we like to clearly separate asset-specific material from material library. In order to do that, we use Slot. Slot provide us two features: layering of material with different BRDF and chaining of material graph to drive material parameter. To use this feature of Slot in USD, we have created a custom schema called Material Slot Binding API. Now let's jump inside Houdini file to see it. In this file, what I'm going to do is I have a dirt material, and this dirt material is a simple diffuse with a mask attached, which has a mask map. And my main aim is to apply this dirt material over other material so that I can have dirt all over the oscilloscope. So now the next thing is I'll assign dirt material to root geoprim, and now I have to assign a slot. As we can see, all the material are assigned to a slot 000, and I want to assign dirt to a higher slot, so I'll assign it to 10. Now I'll hit render, and it renders with dirt. Now this seems like a simple idea, but it does get complex for artists. Now in next section, Balaji will explain how we made it artist friendly. Over to you, Balaji.
Thanks, Ankit. Hello everyone, my name is Balaji, a lead asset TD from Animal Logic Vancouver. Let's talk about USD Shade user interface and its workflow. On the left side, we have a assignment material node, which is a native Houdini assignment material node. On the right side, we have a custom assignment material node, which is developed internally. Both are almost similar. We can add materials like this in the same way, but the main difference between these two nodes is in a custom material node, we have added a Python panel, which is written in Qt, which is similar to our scene graph tree. And the only difference between these two trees is we don't have a material slot or a node over here. Why we need this UI? Let me show you why. In scene graph tree, the materials are there in its own nodes under the material group. So we don't have a direct relationship between a material and its prim. We don't know which prim is assigned to which material. Here, we can directly add materials as a child. For example, I can right click on any geometry in the tree. I can add material. And then here we have a global material list and a material library list, which is coming from this material library. I'm going to pick from one of the material which is already there in our scene and assign a slot value to 000. Select. Now you see in the Houdini panel, we already had a material and its prim and the slot. So if you expand this group, we have materials directly added to this group. It's not just that. All the child prim also inherited the parent material. For example, in this case, we have generic one. It's all inherited, and we can't. These are disabled one, which means that this is inherited from his parent. So we don't have any right click option except the select and override. But in here we can do select, override, and pick, remove, or mute. Mute is nothing but just disable it and also disable all the materials underneath it. And we can do vice versa like that also. So now it's enabled. We can remove materials and it removes this. We can change the prim path over here. So for example, I'm going to change this to root and then refresh here. Now see all the geometry underneath the root, it's inherited this material, which is great. We can see which material is assigned to which prim. And also we can search materials on prims. For example, I'm going to search for handles. It shows all the handle prim or glass materials, which shows all the glass materials. So easy to search and assign materials to the geometry. Let's talk about the slots and override in USD Shade. I have a simple scene open with the light rig and look dev. And this is the current camera view, and this is the render. If you jump into the container, we have some materials already coming from the previous setup, and I'm going to override an existing material, which is a dirt material with a map on it. It's unconnected to the mask, so we can apply that only on the specific area based on the map. I'm going to assign that material over here in as a slot of 000 and select. Right now it's assigned. In the material assignment, you can see the assignment over here, and it's also updated in the child prints. Notice it's not updated on the print because there is already a 00 value in the child prints. To propagate these changes throughout the chain downstream, we can just update to add the slot value to higher value than the current one. Now it is propagate downstream. Now if I do make a render, you can see the depth map is applied on the oscilloscope with a mapper based on the mask. For validation purpose, the slots are strict rules that we can only have 3-digit values. So for example, if I do 4-digit values or something like that, it doesn't allow to do that. And the same for the override. So for override, we need 3-digit colon 3-digit value. So we give to something like 4-digit over here, it doesn't take. Or for override, the colon is important. If I do this, it doesn't work. So this also support slop selection rules, which is in case I can do that. Now if I refresh this UI, now we can have only the plastic geometry is assigned is this value. We change this value to 200. That's it. Now let's solve the plastic value with the 200 slot value. That's all, guys. Thanks for watching. See you later. Bye.
Thanks, Ankit and Balaji. That was a really nice insight. If you guys have any questions, please feel free to visit the Google group for the USD ALab, which you can find as well on our downloads page. Now we're back in the ALab, and if we navigate a little bit down to this shelf, we will find a little entity called Vegetation Bonsai. This is an example of one of our most recent USD improved toolsets called Spruce. It is essentially a toolset that allows us to build trees via point instances. And to walk us through the details, I'll hand it over to Mo.
Hi everyone, it's Mohammed Kamal, Assistant Technical Director at Animal Logic. Today I'm going to talk about the Spruce, our semi-procedural vegetation tool. I'm going to start from the Spruce definition, Spruce basic building blocks. I'm going to talk as well about the Spruce Houdini implementation. First of all, what is Spruce? Spruce basically is a system helping us to construct a tree canopy on a trunk made up of instances of a separately modeled objects and surfaced object as well. So the key feature of the Spruce there, we have the tree, the whole tree is built up from a group of points in a sensor represent tree generation starting from a trunk. So you have a generation that represent the first generation, and the other generation that represent twigs, for example, and generation representing leaves. So when we was working on this one, we started studying some of the natural trees and we're focusing on the two tree elements on while we're studying. Basically, the first element is the branch distribution, which is the most essential part when we work a system like this, where we not be able to deform actually the pieces. We just instance those small amount of prototypes to build a tree or to construct a tree. So the actual point distribution and branch distribution is essential elements in our system, and as well the two other components like a geotropism and phototropism actually. So if you work with the trees, you will find that these two essential natural phenomena or like we can say the behaviors of a tree, where the tree just respond to the light while it's growing, and tree as well respond to the gravity. And those two terms one of them is called geotropism, whereas the plants respond to the gravity, and the other term is called phototropism, where we're going to talk about responding to the light, when the plants or the tree respond to the light. So those three terms is the basic building blocks of our system. The first part, which is the creation of those point distributions that we're going to use for distributing the branches and twigs and leaves. And the second part is the actual geotropism and phototropism. And the last part, we're going to talk about the artist and user experience that we have in this tool, as well as the USD concepts and implementation and some functionality that help us for developing this tool. So the first part is how the Spruce generate those points and how we use point for creating those branches. So first of all, we have something called Spruce data, where we take in the geometry, create a skeleton from the geometry, and then use those two parts to create a bunch of points in the most natural way. This part is happening only in SOPs, whereas we create those points to use it later in LOPs for instancing the points. So in SOPs, we have actually two nodes that our R&D team help us for development those tools. Is following some algorithmic behavior. So if you have here the Spruce branch curves, you have the skeleton, whereas we take the geometry, create a skeleton from the geometry, we take the geometry and the skeleton, and we use it for creating point distribution. And as you see here, the point distribution look natural and not uniform, and not like as other scattering tool. You control every point that corresponds to the skeleton, have create a junction of points, and which is like a group of points, like a circular, as you see here, distributions. And you see here, we can control how many points for every junction you want to see. There's lots of controls about the jittering, and we're going to talk about them when we see the bonsai tool. So this is the basic implementation of the point distribution. The second part, which is the Houdini essential part, whereas we use Houdini for establishing the point instancer, to set instances before the prims and use them for the point instancer, as well the user experience that we have while the artists work on this tool. So Spruce system in Houdini consists of four elements, or more than 4 elements. The basic on the messenger one is a Spruce create generation node, whereas we create this is in instancing the prototypes. So it's have 2 inputs. The first input is the previous generation, and actually the prototypes that we're going to use. The second part is Spruce modify, where artists can modify interactively every prototypes in the viewport. We have a Spruce leaf instance where we are creating we're instancing the leaves. So this one is exclusively for leaves. It's just the same as how Spruce generation work. And we have a pick and place node, whereas it's working on interactively pick and place items on the viewport. So I'm going to talk about right now the Houdini implementation and see how we did the tree in Houdini. Basically, if we have a concept that's called as container. Container is just like an area where the artist can author the tree, and it's just helping the artist to facilitate the exporting process to other departments. So the artists need only to dive in this node and start authoring the stuff that he want to author, or they want to author, and then he can check then those data to other departments. So if you double click on this one, you go inside the worker, you see the actual networks of creating the tree. Basically, the artists need to work on Stage Manager just to drop the prototypes that you want to use and they want to use. If you see, you have lots of prototypes like branches. If you just saw that, this is the whole prototypes that made up our tree. And if you see here, we have the basic one, which is the first generation, is our trunk, as you see. And we started from that. And we start the first generation of us. This is the tool here that's creating the first generation for us, distributing the points using the scatter node, and we have the same controller as I said before. I have a controllers for controlling the growth direction, where I'm talking about all of these controllers is happening on LOPs, directly modifying the USD attributes. And then we have a modify attributes. We can modify the pieces, for example, in the viewport in an interactive way, as well as work in LOPs and work directly on the orient attribute, and using the viewer state for that. We have a Spruce generation node is actually taking the input from the previous generation, which is a point instancer, and outputting a new point instancer on top of it. So if the basic and two elements for the Spruce generation to work is the previous generations. As I said before, the previous generation right now for this generation, for example, is the high resolution mesh and the actual skeleton curves that we used, that we produced using the SOPs nodes. And as you see here, right now we have 2 generations, and we can as well, if you see in the viewport here, is having instanceable items. And we have lost at least Spruce leaf instanza, where we are instancing the three leaves that we have. So this is the leaves that we distribute. There's lots of options here about the same principle like Spruce generation node, but there's options like a leaf de-intersection, a leaf probability, where you can control which part can take which prototypes. Keep Alive, which is the most amazing nodes that we have, is built by our R&D team, is helping us for animating the tree and give some movement to the tree. So there's lots of controllers. I'm not going to describe all of them, but there's a controller over the hierarchy, so you can choose, you can modify the animations over the branches separately than how you do that in the leaves. So this is basically the basic implementation of Spruce. And as well, I haven't talked about the actual interactive placement. So you can place items in Spruce like this. See here, and you can choose which item that you want to use for this one. I'm going to use, for example, 2 or 3 here. So you can as well control the items that you see here. So you can add as much as you can, and then you can use them later on the other generations. I'm going to see right now the other terms of what you can say is the other USD implementation that that Solaris help us a lot of it, like a GViz variant, establishing some variant set, and as well establishing the value clip to use data for creating some loop animation. Basically, I'm not about the variant set. Variant set is actually a way of switching between options, we can say, or just like it's changing the structure. Because we right now, when we create this tree, we have two ways of creating two structure. For example, we can say the actual tree is created as a point instance, but the actual mesh, proxy mesh, is actually built in a different way. So we want to help the other department or facilitate the other departments to switch between those options as in a form of variant set. I want to show you, going to show you that. So I'm going to show you right now the basic and useful implementations of variant sets. So if you're going to see here, we have GViz variant. If you work or you see the lab tool or the USD lab assets, it's called Bonsai, you will find the GViz variant to switch between the higher definition and a preview version of the tree, actually. This is one of the usage of variant set nodes that we have in Solaris. And as well, now I'm going to talk about the last things is the value clip. Value clip is like how you do video editing on like a normal video editing tool, but it's actually in USD when you work in the timestamp attribute. It's actually we trying to save or export cached a small period of small animation range, and actually trying to create a loop animation over it. And the basic and the most useful implementation is using the value clip nodes that are value clip USD functionality, but with the help of the Solaris implementation. That we see here right now that we have a cached item with 100 frame and stop. We need to do a loop animation for 6,000 frame, for example. Use a value clip is we just need to select which frame or which structure we're going to use for the looping, which is the default GViz variants, where we have the actual representation of the tree, and we have the clip of the same clip that we use, but with a specific frame range, and then we can just say this side how many frames we want to see this one is looping. So if you just select this one, you see right now it just do loop animation over them. That's it for today. Thank you so much.
Thanks Mo, Ankit and Balaji for walking us through these details. As we have seen, Houdini is a great platform to interact with USD and has allowed us to integrate studio-specific tools in a robust way. We'd like to give special thanks to everyone involved in our teams at Animal Logic. From artists to TDs and our R&D teams, everyone has been helping contributing to these USD workflows. A huge thanks as well to everyone involved in allowing ALab to exist out in the wild as a 30th birthday present to the industry. We aim at encouraging further collaboration and exploration with the wider community and for everyone to learn from each other. This has been a long journey and a huge learning experience for us at Animal Logic. We continue to improve the way we use USD, and if you'd like to be part of this, join the online discussion and our Google group. Or even better, come and join our teams. We have exciting projects coming up and are hiring in all sorts of departments. Thank you everyone, and see you around.